Hello everyone, welcome again in this new tutorial. So today we will learn a trick, and it's very good practice to be used, especially for beginners, for those who design their own PCBs, and even I believe for the advanced designers. I'm sure most of them, they are not aware of this trick or this issue actually. So before I talk to you about the trick or the solution, let's start with the issue first, or the problem. Okay, so let's say we have this PCB board. We designed this PCB board, so I cannot show you all. So let's start with this connector. Okay, is a 3x6 connector. So let's take a screenshot of one pin. Okay, let's say this one. Let's take it to the pins. Okay, so here we have our, where is my pen? Okay, here our trace is here, and also our this pad. So this pad, you can see here, we got a hole where the pin will go inside. Okay, this hole, the PCB manufacturer, they will use a drill bit to drill the hole here. Okay, however, I'm pretty sure that the fabricator, the PCB fabricator, they are not that accurate. Even the machine that not that accurate, especially for such kind of small holes. I'm sure is very, very small in size, like less than a few mm. Okay, so most of the time the holes will be offset to one directions, which will lead to a loss of the connection between the trace and the pad, or might be very weak connections. Okay, for example, if the hole slip or due to some issue, the hole doesn't come into the center, but it might come to here or maybe here. Okay, so in this case, you can see the communication or the connection between the trace and the bed become very weak. Okay, might come to here. Even the worst case might be totally disconnected. Okay, and that might lead to very serious issues in noise issues, and also no stable signals. Okay, especially for the high frequency application. Or RF. Okay, so to solve this issue, let's say the hole come here. Okay, the little bit's been shifted. So to solve this issue, we use some sort of technique called teardrop. Teardrop, okay, is a method by adding more lines, to the points where the trace meet the bed, which is this point. How to make it more clear? Okay, this point, sorry. Okay, this point where the trace meet the bed, this point, sorry, we will add more lines. Okay, like this. Okay, these lines will be for sure connected to the trace from one end, another end will be connected to the bed. So with this technique, we cannot prevent 100% of this issue of the drill bit slip, but we can reduce the effect. If, let's say, slip to here, it still got solid connection between the trace and the bed. Okay, so this is the issue, and this is how we solve it. The issue is the holes might not be centered, might be offset. This leads to less connecting resistance between the trace and the bed, or might lead to totally disconnected, or some issues regarding the noise and floating this signal. Okay, so how to solve it? We come back to our inline circuit. So you go to the ULP, then we search about teardrop. Here it is. We open it. Okay. From here, we can see for the parameter, usually I will not touch the parameters. From here, it's make very nice and consistent teardrop for all. I just use, I check that I need the teardrops for VIA and PET as all. And also the top and buttons layer are activated. If you don't want to change, you just double click, then you say, okay, I don't want on this layer, or we want to add more layers. Okay, so for me, I want both this one all okay. I press teardrop my board. So now it's connecting. Okay, if you can see here on the top is counting the percentage, now 30%, 37%. So if you see now, it start to add my teardrop to the PCB. So let's give it time to finish it. Okay, it's done. You see? Okay, before that, all these lines are, I mean, without these lines, okay, you just straight, what they call trace directly to the bed. Okay, same goes to here. You see now it's at this teardrop shape at the point where the trace meet the bed. So this one will give high chance of good continuity between the trace and the bed. Same goes, let's say, if we are here. This is some vias also. Exactly for the via, you see, I believe it's less than 0.5 mm. So it's very high chance, got very high chance to slip on which side, on any side. So with this teardrop, can improve the connection between the points. Okay, same goes to here. You see. Okay, so with this method, we have solved a very expected issue from any suppliers or any PCB fabricator. So we don't want to depend 100% on the PCB fabricator accuracy. We want to take our own precautions. If worse come to worse, we already have our precautions to overtake the issue. So I hope you have learned something new this time, and please use this and practice it in your next design. Thanks, and please let me know if you need any further explanation or you have any question. Let me know in the comments down below. Thanks, and have a nice day.